Hello everyone, and welcome back to Flying Through the Gyroplane Flying Handbook. In this video, we're going to look at the second chapter, which is technically chapter 16, on aerodynamics of the gyroplane. Now, in particular, in this video, we are going to talk about autorotation. So what exactly is autorotation? Well, if you're flying a helicopter, autorotation is the thing that allows you to fly when your engine has failed. In the case of a gyroplane, autorotation is what allows you to fly in general. So there is a very big difference in an autorotation in a gyro versus a helicopter. And it's related to how they normally fly. So if you look at a gyroplane, normally the wind is coming up from below the rotor. So it's rushing upward, and that's causing the rotor to spin. We're going to talk a little bit more detail about exactly how that works here in a bit, as opposed to a helicopter. So in a helicopter, the engine in the rotor is causing air to be sucked down through the rotor. And that's a big difference. So in a helicopter, if you have an engine failure, you have to transition into an autorotation. So there's a little bit of time there where you're going between this situation where the air is going down through the rotor to the situation where it's rushing upwards and causing the main rotor to spin. And because it's connected to a transmission, it will also cause the tail rotor to spin. So if we look at an autorotation, we can look at the wind that is hitting our airfoil. So we have two components for that wind. We have the wind that is due to the blade rotating, and then we have the component that is due to the rotor essentially falling through the air, if you will. And that gives us our resultant wind, our resultant relative wind. Now, if we look at what's going on with our rotor system, we can look at different points. And let's say we're out here at the tip, and we have a 12.5 foot rotor, and we're going at 300 rotations per minute. Our speed is going to be 267 miles per hour, or about 400 feet per second. That's our rotational speed. Our upward flow of air is going to be something closer to 25 feet per second, or 17 miles per hour. Now, as we move inward on that rotor span, the rotational airflow is going to drop a lot because this radius is greatly reduced, and the upward airflow will remain the same. So our relative wind starts to be tilted more and more upward. As a result, we get our rotor divided into three different regions. So we have this outer region. This is called the driven region. And if you look at this part of the figure, you'll notice that what is happening is that the total aerodynamic force being produced by this airfoil is tilted backward. And as a result, you can say some of that aerodynamic force is going to be lift, parallel to weight, and some of it is going to be drag. So this is going to resist having the rotor turning. This is also sometimes called the propeller region because this is where you're getting most of the lift. So this is what happens if we're falling straight down, which we can always do in a gyro. We'll talk about how it's slightly altered if you're actually going forward in flight, as you typically would be. Now, as we go in, again, now the inflow of air is starting to become more upward, and we get into this yellow region, which is called the driving region. And what's happening here, if I look at the total aerodynamic force, it is tilted forward of the axis of rotation, and it's causing lift, but it is also causing the rotor to want to spin. And that's why it's called the driving region or autorotative region. And then finally, we get to the center region. The center region is the stalled region. It's just not moving fast enough. It doesn't have enough air moving over it to really do anything. It's just kind of there. It's there keeping this rotor together. And you'll notice in this picture, they have a really thin region in the middle, which is kind of typical. You've got your rotor head where everything is attached, but there's no real point in extending that airfoil to the very center of the rotor because that's not moving fast enough to really matter at all. So this is what happens if you're doing an auto rotation and you're going straight down, which we rarely are. So how does that change if I start going into forward flight? Now, this is something that, if you look at the aerodynamics section for helicopters, or perhaps you look at my Flying Through the Helicopter Flying Handbook series, we talk about this a bit. And this is easy to understand. The forward flight situation is just slightly different. Two things happen. Number one, all of these regions get pushed toward the retreating blade, which is often the left blade in a helicopter and a gyroplane. Most of them spin this way. So you see the stalled region is just a little bit offset. Driving region, same thing. And driven region, same thing as well. So it's not all that different. Now, one thing that we do talk about with a gyroplane in particular is this idea of reversed flow. So if you look at this figure, you'll notice I'm going forward at 42 knots and I'm rotating at 300 rotations per minute. And if I go out to a distance of about 2 feet from the hub, my rotational speed is also 42 knots. So if I look at this one little point here, what I'm going to see is that the airspeed of the air flowing over that is 0, because I have this inrushing air at 42 knots, but this is retreating away at 42 knots. If I go inboard from that point, now the onrushing air is faster than the blade is retreating from that air. So in other words, now the air in this yellow section is flowing at a speed where it actually goes backwards. Instead of starting at the leading edge, it actually flows from the trailing edge forward. Now, if I go too fast in my gyroplane, I can get this thing called retreating blade stall. Now, in a helicopter, retreating blade stall is sort of a bad thing because it happens out at the tips of the rotor. But because of how things work when we're in auto-rotative flight, which we always are, instead of happening at the tips, this is going to happen in that 20 to 40% position. So what that means In the case of a helicopter, if you have retreating blade stall, you're going to experience large pitch and roll tendencies. You're going to get some vibrations. The thing's going to pitch up and then it's going to roll over on its side. But you won't have that in the case of a gyro. Instead, in the case of a gyro, what you're going to experience is a slight increase in vibrations. The thing is not going to roll over on its side or anything, but that retreating blade stall, as you go faster and faster, can increase the vibrations. Now, later at some point, we'll talk about retreating blade stall as it applies to being on the ground when you're taxiing around with a rotor that's spinning. But we're not going to talk about that just yet here. Okay, so let's go ahead and see what this means in reality. We'll go to our simulator. Okay, just for the sake of time, I'm going to go ahead and start in the air. So I'm in forward flight at the moment, but I'm going to try to get it way down to where I'm at about 0 forward airspeed. So I've throttled all the way back. And you'll notice, even though my airspeed is going way down, my RPMs on my rotor are staying about the same. Now, the other thing, which you'll definitely notice in an actual machine, is now that I'm going really slow, my rudder pedals are kind of sluggish here. And check out that descent rate. It's pretty high, around 1,000 foot per minute. All right, so if I want to land this successfully, I'm going to have to get some of that airspeed in there. Bring it back down. So I'm back on a downwind here. I throttle back a bit. And still an auto-rotative flight. I'm always in auto-rotative flight in the gyro. So what does that mean? It means if I want to fly level, essentially my power setting is going to determine my speed. So right now I have around 4,700 RPMs. It's a pretty low power setting. I'm doing right about 80 knots. If I want to come in for a landing, I'll throttle back a little bit, start slowing myself down. Kind of bring myself around. Now, if you're, say, a transitioning helicopter pilot, one thing you're going to learn is that unlike a helicopter, you pretty much want to lawn dart this thing into the ground. And what do I mean by that? You want to keep that speed up. So I'm doing about 60 here, which is appropriate for this particular machine. I want to keep it up to 60. I'm going to get down here to about 20 feet or so. I'm going to slowly start pulling up a little bit. And I want to just touch down nice and gentle. I can actually come back a little bit, and that will slow me down right away. If I hold it back, by the way, it's going to actually end up having me go backwards, which is not what I want. Okay, so I know that was pretty quick, but I think you get the idea. Autorotation is an important thing to understand, but you know, there's not a lot to be done in a gyro. Either You're flying or you're not. And whenever you're flying, guess what? You're in an auto rotation. So that's all for this video. We'll see you in the next one.